Welcome everyone. Today we are starting with our next topic, and that is 3D, right? So we are going to cover 3D transformations basically here. So first we come across with what is 3D, right? Till date in computer graphics we have done everything related to two-dimensional, and that was your two-dimensional thing wherein I want to have X and Y. That's it. So X gives me the width of the object, Y gives me the height of the object. Okay. But the moment I move to 3D, I have X, Y, that is width, height, and Z. So this Z gives me the depth of the object, right? So Z in a positive direction and Z in a negative direction, much more similar to your X in a positive direction and X in a negative direction, or Y in a positive direction and Y in a negative direction, right? So this is nothing but your Z parameter that will give you the depth. So any object that I have here will be shown in 3D. So this is the object that we will be having in 3D, and that's how it will look in your three-dimensional domain. Okay, so this is all about the difference between your two-dimensional and three-dimensional. Now we come across to what is your 3D transformations, right? We have covered 2D transformations very clearly, and we know so we start with our 3D transformations, right? The job of transformation is to change the location of the object, or to increase the size of the object, or to rotate the object. So there are various transformations. So what we all are going to see in 3D is 3D translation, 3D rotation, and 3D scaling. Okay, so first we come across to three-dimensional translation. So that's our first transformation that we are going to see. Now I will be drawing my three-dimensional coordinate x, y, and z out here, right? Any point in 3D is given by x, y, z. So my point coordinate in 3D will be x, y, z, and a 1. Right? My point coordinate in 2D was x, y, 1, right? So now in 3D, I've got one more parameter, that is z. So this becomes a 4 cross 1 matrix, 4 rows and a 1 column for a single point, right? So we all also know that if it's a line, then I'll be having 2 columns. If a triangle, I'll be having 3 columns, so on and so forth. As the number of vertices go on increasing in the object, the number of columns in my point matrix will also go on increasing, right? So our first transformation is 3D translation. That means I want to shift this object to say this particular location, right? And this becomes my x dash, y dash, and z dash, right? We have also seen the formula to do this. X dash is equal to x plus tx, y dash is equal to y plus ty. This is what we know in 2D. Now in 3D, I will also add z dash is equal to z plus tz. So one more translation vector added, that is tz. So now my translation matrix will have tx, ty, and tz. So three translation vectors out here. Okay. Now how do we write the matrix? So the formula goes like P dash is equal to T multiplied by P. As we are using homogeneous, so everything will be multiplication. The homogeneous description is already given to you and you know about it. Okay, so we just write down the matrix, right? So it is 1 0 0 Tx, 0 1 0 Ty, 0 0 1 Tz, 0, 0, 0, 1. So now my matrix turns out to be a 4 cross 4 matrix. In two-dimensional, this was a 3 cross 3 matrix. That's a translation matrix. Now in 3D, this becomes a 4 cross 4 matrix. That is your translation matrix. Okay. And whenever you want to inverse it, right? So translation, this is my translation matrix. And if I want to have inverse translation matrix, it will be minus tx. So I can write my inverse translation matrix as minus tx minus ty minus tz, right? The rules remain the same as in the way we have done it in two-dimensional, only the size of the matrices do change here. Okay, so this is your 3D translation. Now we move on to 3D scaling. Okay, now if I want to do 3D scaling of any object given to me, so that's x, y, and a z, right? And if I pick up the object as something like this, and I say that the the scaled object should look like this, right? So this is a good example of your scaling, wherein this is P and this is P dash. So P is original and P dash is your final matrix, right? So what happens when I'm doing scaling? We will talk in terms of formulas. So it is x multiplied by sx that gives me x dash, y multiplied by sy that gives me y dash, z multiplied by sz will give me z dash, right? So this is the new scaling factor that is added. So my scaling matrix will have sx, sy, and sz. So three scaling factors out here, right? And when I want to put up my matrix, so p dash is equal to s multiplied by p, and we just write down the matrix of s. Again, it's a 4 cross 4 matrix. So it is sx 0, 0, 0, 0, sy 0, 0, 0, 0, sz 0, 0, 0, 0, 1. So this becomes my scaling matrix. Now, if I know scaling matrix, how do I write down inverse scaling matrices? 1 by sx, 1 by sy, 1 by sz. The rest of the rules remain similar to your 2D scaling. That scaling factors sx, sy, and sz will allow any value equal to 1, will allow any value less than 1, will allow any value greater than 1, but then the values have to be positive, right? And a 0 is not acceptable, right? So these are the conditions for your scaling, similar to your two-dimensional scaling. The size changes to of your matrix changes, right? Next, we move on to 3D rotation. Now students, please pay attention here. This is a bit complicated. Okay, so when I start with 3D rotation, rather we first move on to 2D rotation. So it is x and a y. So any point P, x, comma, y, if I want to rotate it, right? What did we do? We considered a reference point out here, that is origin. I rotated it as per the reference point by angle theta, and then I find out the relative output, that is p dash, x dash, y dash, right? So this is angle theta for me. I'm going in anti-clockwise direction, so that's why my my theta is positive, right? Now, how we wrote the formula as x dash is equal to x cos theta minus y sine theta, and y dash is equal to x sine theta plus y cos theta, that is for positive theta, right? So this is what we have written, and using this I got cos theta minus sine theta 0, sine theta, cos theta 0, 0, 0, 1. So this was my R matrix, in which case in two-dimensional case. Now we see what happens in three-dimensional case, right? So I will just be drawing my three-dimensional x, y, and z, right? Now, please remember that any point represented using X, Y, Z. Okay. Now, do also try to understand that when I am having two-dimensional, I have got a single plane here, and that is my XY plane. So my point remains on this plane only. But when I talk about three-dimensional, I have got one plane as my XY plane. So this is my XY plane, right? I have got another plane as this plane. This is YZ plane. And I've got my third plane as this plane, and this is XZ plane, right? So now my point could be, after rotation, it could be in XY plane, or else it could shift to YZ plane, or else it could shift to XZ plane. So I can do rotation like this. I can do rotation like this. Yes, so this is anti-clockwise rotation, or else I could move only in this point, that is inside this XY plane only. Right, so this is how I perform rotation in three-dimensional. Right, so if this concept is clear, that means I cannot take origin as the reference point like I took in two-dimensional and say that this will be my reference line, and say that this will be my reference line, and I'll try to move my object taking this reference line into consideration, because now we are talking about 3D. So this cannot happen. So what we need to do, students, is when I am in three-dimensional, that is X, Y, and Z, I will do rotation about an axis. Right, so if I am taking my x-axis into consideration and I am rotating my object taking x-axis into consideration in anti-clockwise direction, suppose, right? So my point is here, that is PXYZ. So what will happen to my point? My point will shift onto the YZ axis, right, nearly to the YZ axis. That means my X is not changing, and what values are changing? Y and Z are changing in that case, right? So this is when I'm talking about X axis rotation. Similarly, when I am doing my Z axis rotation, suppose I'm picking up Z axis rotation. So what will happen? I'm talking about which points? My Z is not changing, but my X and Y are changing, right? Similarly, when I talk about y-axis rotation, what is changing? When I talk about y-axis rotation, my z and x are changing, but my y is not changing, right? So whenever I do my rotation in 3D is with respect to an axis, right? Either it could be x-axis, y-axis, or z-axis. Now we quickly look at the formulas to do it. Okay, so our first rotation is 3D rotation about z-axis. Okay, so this is x, y, and z, right? So we are doing rotation about z-axis. So any point P, X, Y, Z in 3D, right? And I am moving in which direction? Anti-clockwise direction. So my point would go out here. So which values are changing, students? When I'm doing z-axis rotation, my x and y are changing, right? So I will write my x dash as x cos theta minus y sin theta, and y dash as x sin theta plus y cos theta. Okay, and my z dash remains as it is. Now we see what will be my formula looking like. X, Y, Z, 1. This is my point matrix multiplied by my rotation matrix. Now it's a 4 cross 4 matrix, students. So X is multiplied by cos theta, Y is multiplied by minus sin theta, and rest two values 0. Similarly, X is multiplied by sin theta, Y with a cos theta, and then 0, 0. The next is Z dash is Z. So it's a 0, 0, 1, 0. And last row is 0, 0, 0, 1. So this becomes my rotation matrix. This is my R matrix for positive value of theta, but then now in which direction? In Z direction. So this is RZ matrix. Okay. Similarly, now we see the second matrix, and that is our second rotation transformation is 3D rotation about x-axis, right? So x, y, and z. And now we are going to see rotation about x-axis, right? So looking into the object from this direction, that is x direction, and rotating it in an anti-clockwise direction. So any point P, X, Y, Z on my 3D coordinate system, taking x-axis into consideration, I will perform the rotation in this direction. So my point that's in 3D will either go to YZ plane or else it will go to XZ plane. So that is 3D rotation about x-axis. And now we also know that whenever I'm doing 3D rotation about x-axis, my x coordinate won't change. What will change is my y will change and z will change. So we try writing the formula using y and z, right? So it is y cos theta minus z sin theta, and it is y sin theta plus z cos theta. X remains the same. Now our matrix. So I am also writing my P matrix here so that we understand what are we multiplying it with. Now x dash is equal to x. So my output x dash, y dash, z dash and a 1. So x dash is equal to x. So my first row will remain 1 triple 0. My second row is y dash is equal to y cos theta minus z sin theta. So y has to be multiplied by cos theta. X has to be multiplied by nothing. So y is multiplied by cos theta and z is multiplied by minus sin theta and a 0, right? My third row is z dash. Z dash is equal to y sin theta plus z cos theta. So y to be multiplied by sin theta, z to be multiplied by cos theta and a 0. My last row is 0, 0, 0, 1. So this becomes my rotation matrix about x-axis and with positive theta. So rotation about x-axis and angle is positive theta. Now we move on to our third rotation matrix, and that is 3D rotation about y-axis, right? So this is x, y and a z, and we are moving in terms of y-axis. So this is the axis. So I'm looking into the object from this side. Okay, so if I'm looking into the object from this side, my anti-clockwise direction would be this. Okay, so if this is my anti-clockwise direction, so any point P, X, Y, Z on any 3D coordinate of your system will move on this side, right? So what will change? My y will not change. What is going to change? My z and x are going to change. Okay, so my y will remain same. My y dash will be same as y, right? What will change? X dash will change and Z dash will change, right? What will it change to? That is what we are going to see. So I'll just put this up on the left hand side corner. And so my Y dash will remain as Y, my X dash will change and my Z dash will change. Now we see what changes in Z and X, right? Now as my Y is the reference axis, so the first point to be changing is Z and the next point to be changing is X. Why am I saying so? Because when I was doing X-axis rotation, it was YZ that was changing. When I was talking about Z-axis, it was XY that was changing. So when I'm talking about y-axis rotation, it is zx that is changing. So please remember, students, the order in which your points are getting shifted in your formula. So for z, now my formula goes z cos theta minus x sin theta. And for x dash, it is z sin theta plus x cos theta. Right, so there is a bit of change in the order of your coordinates here. So for xy, it is x first, y next. For yz, is y first, z next. For zx, it is z first and x next, right? So it is z cos theta minus x sin theta, and x dash is z sin theta plus x cos theta. Now we write the matrix x, y, z, and a 1, right? So my output is x dash, y dash, z dash, and a 1, right? So when I talk about x dash, it is z sine theta plus x cos theta. So x has to be multiplied by cos theta, y with nothing, z has to be multiplied with sine theta and a 0. Y dash is same as y, so 0, 1, 0, 0. Z dash is z cos theta minus x sin theta. So x with a minus sin theta, right? And z with a cos theta, 0, and last row is 0, 0, 0, 1. So this becomes my rotation about y-axis, taking angle theta into consideration. So these are your three rotation matrices. Please do remember the formula is only one. It is x dash is equal to x cos theta minus y sin theta, and y dash is equal to x sin theta plus y cos theta. What you need to do, students, is whenever I'm talking about whichever plane, you need to change these coordinates accordingly. That's it, right? So when I'm talking about YZ plane, it is replaced with Y and Z. When I'm talking about XY plane, it is already XY plane. When I'm talking about XZ plane, the order changes to ZX. So ZX, ZX, right? So this is what you are supposed to remember whenever you are doing 3D rotation about any of the axes that is taken into consideration, right? So this is all about your 3D transformations. Now in our next session, we will be seeing 3D projections and how to do projections and what are the different types of projection. So stay tuned for our next session.